Good afternoon, class. Till we had discussed about the various topics in the you can say the complex numbers. We had studied about various type of numbers earlier also. In this class, we are going to study about a new concept, which is totally new concept for the you can say the person who is dealing with the mathematics. It is basically the complex numbers. In earlier classes, we had discussed about the natural numbers. Different kinds of numbers are natural numbers are there, rational numbers are there, irrational numbers are there, fractions are there, and we had seen the various consequences related to the same. Today, we are going to discuss about a new topic, that is complex number. First and foremost, we will be switching over to the natural numbers. What are natural numbers? As the name suggests, the natural numbers are the numbers which is initiating from the natural numbers are basically counting numbers. They are starting from the 1 and they can go up to infinity. So we have discussed about the natural numbers. It is natural number. Natural numbers or counting numbers. As we had seen earlier also, previously we had discussed all the numericals, all the concepts based on the natural numbers. The natural numbers are the counting numbers which are starting from the 1 and they can go up to infinity. That is, you can say, we can write 1 to infinity. The set of, it is a universal set containing 1 to infinity, and that is basically the natural numbers or the counting numbers. Secondly, we had came across whole numbers. Whole numbers are the numbers which, if we are associating 0 and with the counting numbers, then they are basically the whole numbers. They are basically the whole numbers. Sorry. So the natural numbers are the numbers which we are entitling that as counting numbers, and they are starting from 1 to and they can go up to infinity. Whereas the whole numbers are the numbers which are starting from 0 and they can go also up to infinity. Third is the rational numbers. Third are the rational numbers. They can the whole number, it is starting from 0 and it can go up to infinity. Third is the rational number. Rational numbers, as the name suggests, the rational numbers are the numbers which we can represent that numbers in the form of p by q, where q is not equal to 0. If q will be equal to 0, then that particular number will be termed as infinity. Suppose we can write here, as I had already elaborated, what are natural numbers, what are rational numbers. Rational numbers are the numbers which can be represented in the form of p by q, where q is not equal to 0. Suppose I am writing rational number as 3 by 4. So I had represented this particular fraction 3 by 4 in the form of p by q. Understood? Where q is not equal to 0. So q is not equal to 0 in this case. So we can say, it is mathematically stating, we can say that this particular number is a rational number. Understood? Secondly, if in this case 3 by 0, understood, the q is equal to 0, in this case q is equal to 0, this is q. So this is q is equal to 0, in that case, then that particular number, that particular fraction, it will be turned as infinity, because anything to the power to the denominator 0, we can say it is infinity. Third is irrational numbers. Irrational numbers. Irrational numbers are the numbers which I had already stated. The rational numbers are the numbers which we can represent in the form of p by q, that is in the form of fraction, where q is not equal to 0. In the case of irrational number, we can't represent that particular fraction in the form of p by q, and that in that case also q will not be equal to 0. So in this case also, suppose irrational number, we had said root 3 it is there, root 2 is there. So these are particularly irrational numbers where we are not able to represent that particular fraction part in the form of p by q. And secondly, the second condition is q is not equal to 0. I am discussing this type of numbers because we had encountered such type of numbers: natural numbers, whole numbers, rational numbers, and irrational numbers. Earlier we had discussed all the types of numbers. We had came across different type of concepts, numericals. We had saw numericals also, in which we had used this type of nomenclatures. But now, as of now, we are going to discuss about a new number, that is a complex number. In other words, we can say it is entitled as imaginary number. So we will be switching over to the complex numbers. So the complex numbers, as I had already stated, complex numbers are also entitled as irrational numbers. Sorry, complex numbers are also entitled as imaginary numbers. Imaginary numbers. In other words, we can say this type of numbers didn't have any existence, but they exist. So in this case, we can say complex numbers are entitled as imaginary numbers. Anything, suppose we can say, for example, what are the examples of complex number? Under root minus 3, under root minus 1. These are basically the imaginary numbers. In the real world, in the realistic approach, we will not be able to find the values of under root minus 3, under root minus 1. These numbers are basically the imaginary numbers or complex numbers. These are entitled as complex number because it is not so easy to manipulate or to evaluate the value of under root minus 3 in the real sense. Understood? And these numbers we are using for in these, the complex number have various type of applications in the field of science and in the field of mathematics also, which we will be discussing and which we will be seeing when we will approach gradually or mechanically. So first and foremost, we will be saying the different notations, the different nomenclatures, how we are describing the complex numbers. First and foremost, it is under root minus 1. This is the basic thing, under root minus 1, which we are writing as I, and this is I, it is known as iota. In the complex number under root minus 1, it is denoted as I, and we can write that particular I as a simple notation, that is iota, which we are telling in the you can say general sense, it is iota. Understood? Similarly, if it is I square, if we have to evaluate the formula of if we want to evaluate the value of I square, we can write here I square will be under root minus 1 into under root minus 1. That is under root minus 1, under root minus 1 ka whole square, it will be under root minus 1 ka whole square, it will be 1. I square is equal to minus 1. So we can say I square is equal to minus 1. Regarding the simplification, regarding the process to solve, the working mechanism, the modus operandi which we will be using in this case to solve the complex numbers, that is equivalent to the concept which we had used to solve the numericals that are existing within the subset of universal number, or we can say it is in the natural number. So both are having the same process, but regarding the applications, in that if we are saying the aspect of application, both are having different concepts. So we will be gradually moving forward. I cube, suppose it is I cube, it is there, we can write it, we can bifurcate I cube into two parts. I square is equal into I. So I square, which we had already evaluated, minus 1 into I. So I cube will be equal to minus I. Understood? Now we will be switching over to the I4, I to the power 4. I4, which we can write in the term of indices, I square into I square. I square we had already evaluated, minus 1 into minus 1 is equal to plus 1. So we had seen how easily we had evaluated some of the notations, some of the basic notation based on which we will be solving the complex formulas, or we can deduce the complex derivations. And furthermore, it will be having a ripple effect on the numericals also. First and foremost, under root minus 1, it will be denoted as I, which we can say it is iota. I square is equal to under root minus 1 into under root minus 1, the same concept which we had applied in the case of natural numbers. It will be under root minus 1 the whole square, it will be minus 1. I cube it is equal to I square into I square it is equal to minus 1 into I, it is equal to minus I4. I4 is equal to I square into I square. Suppose I4 it is which we had already studied, I4 I square into I square it is minus 1 into minus 1, and that will be plus 1. So we will be writing here in the separate column all these values, so we can use it as a basic thing. Under root minus 1 is equal to I square is equal to minus 1, I cube is equal to, it will be equal to minus I, and I to the power 4, it will be equal to plus 1, sorry. So these things we had seen, and we will be slowly moving to the some of the more concept which will render some more transparency while solving the complex numerical problems. Now we had seen up to power 4, the indices, the complex and the indices up to the power 4. Indices up to power 4. We had seen this. Now, if there is a problem, suppose we have to evaluate, we have to calculate the value of I to the power 51. Suppose it is written here I to the power 51. We have to calculate the value of the same. One of the latent concept is that if any power if it is greater than 4, in that case we will divide that particular number with 4 and we will check what is the remainder, and that remainder it will be raised to the power. Suppose it is 51, it is given here, we will divide 51 with 4. So we will be getting 4 1 is 4, 4 2 is 8. So we have got the remainder as 3. As I had already stated, this particular 3, so we will be writing here I51 is equal to I3. And we have seen I3 is equal to minus I. So finally, the value of I to the power 51, it will be equal to minus I. So the concept is that if any power which is greater than 4, in that case, if any power is there, if it is greater than 4, in that case we will divide that particular number with 4 and we will check what is the remainder. If in case the remainder is given here 3, so we will raise the same remainder which is there in the power. Suppose I to the power 51 is there, so the remainder is 3. We have seen I to the power 3 and it is equal to minus I, which we had already deduced. We will be seeing some more complex problems in this case, so that our concept will be more easier, will be more simplified. We will simplify some of the doubts here. We will check the concepts. Suppose it is written here I to the power 513. We have to calculate the value of I to the power 513. So in that case, similarly, I had already stated that if the power, suppose I to the power n, and n is greater than 4, in that case we will divide that particular power with 4. So 4, 513, so 4 1 is 4, 4 2 is 8, 4 8 is 32. So in this case, we had got the remainder as 1. So now we can write I to the power 513 as I to the power 1, and I to the power 1 is I. I to the power 1 is I, that is I to the power 1 I, it is under root minus 1. So this is the basic concept, how we are calculating the values of some of the basic nomenclatures. So this is the basic thing which we have studied. Now we will be solving some of the numerical problems which will be easy for us now, so to us to solve the problem. Before that, I will be just switching over to the complex numbers. In that we will be seeing the real part and the imaginary part. The real part of the number and the real part and the imaginary part. Any complex number, the concept is any complex number which is in the form of x plus iy, and the complex number, it is written in the form of z. So a set of prior to that we will see some of the concept. A set of natural numbers, a set of natural numbers, natural number, it is denoted basically by n, capital N. Set of the natural number, it is denoted by capital N. A set of rational numbers, a set of rational numbers, it is denoted by capital R. Okay, and a set of integers, set of integers, it is denoted by capital I. Similarly, a set of the complex numbers, similarly a set of complex numbers, it is denoted by, a set of the complex number, it is denoted by using the number z. So we can write any complex number having both the wings in real part as well as imaginary part. So we will see z is equal to x plus iy. We have already told you, we will see how we are bifurcating, how we are writing a complex number in two parts, bearing the real part as well as imaginary part. So in this case, we have already seen we can write z is equal to x plus iy. Z is equal to x plus iy. Z is equal to x plus iy. We will write here z is equal to x plus iy. So we had seen here how we are writing the complex numbers. Any complex number can be written in the form of two parts, having real part as well as imaginary part. So in the x, we will write here it is a real part, and the second part, this one, we can write here it is imaginary part or complex part, imaginary part. So we had seen how we are writing a complex number into two parts, that is having real part as well as imaginary part. So we will see some of the basic numericals, and we will solve some of the more numericals in this case so as to render more transparency on the concept. First and foremost, the concept which we had studied earlier regarding the iota, on that only we will be solving some of the problems, so that our concept will be more easier and we will be trying to resolve the case as soon as possible. Some of the concepts are there. First and foremost, we have to evaluate the following: I to the power 135. We had already studied the concept. If the power raised is greater than 4, in that case we have to divide that number with 4. So in this case we will be dividing 135 by 4. So 4 is a 12. 4 is a 12. So we can write I to the power 135 as I to the power 3. I to the power 135, we can write I to the power 3. And I to the power 3, I had already told you, we can write here I square into I. I square is equal to minus 1 into I. So finally, I 135 can be written as minus I. That is the concept. Second, we will see one more concept. Suppose it is written here I to the power minus 999. Suppose one problem is there, I to the power minus 999. So we had already seen, if any power is negative, we can use that particular negative power, and we can write it in the form of p by q. So this can be written as I to the power 999, 1 by I to the power 999. Similarly, we will be solving this particular problem using the same concept. The concept is, if it is 999, it is greater than 4, in that case we will be dividing 999 with 4. So 4, 999, 4 to the 8, 4 4 is 16, 4 is 32. So we are seeing here that it is basically 4 is 32. it will be written as 1 to the power I to the power 7, because the remainder which we had got, it is 7. Again, we are seeing that it is greater than 4. This particular power, it is again greater than 4. Again, we will be dividing that power with 4. So 7 divided by 4, it will be 3. So we are getting 1 by I to the power 3. And I to the power 3, I had already deduced that it is reduced to minus I. So 1 by minus I. 1 by minus I. So it is basically minus 1 by I, or minus I to the power minus 1, or minus I to the power minus 1. That is basically the answer in this case. So we will be solving some of the complex formulas, and based on which our problems, the concept will be more easier. So we have seen some of the formulas here and the problems. It is easy only. We will be solving one more problem so that our concept will be more easier in this case. Understood? We will be solving some more problems. Complex numbers are having the different type of applications. It is not so simple, but because it is written here that we have to bifurcate any complex number in the two parts, that is real part and the imaginary part. The real part and the imaginary part, and the process to solve will be similar as that of the natural number, the concept which we are using in the natural numbers. Understood? Now we will be seeing some of the more concept. Suppose the question is like that, we have to prove LHS equal to RHS. We have to prove that I to the power 18 plus 1 by I to the power 24 to the power cube is equal to 0. This we have to prove that this particular expression, which is the blend of summation of two of the imaginary problems, which we have to equate it to 0. That is, we have to prove LHS equal to RHS. So we will be solving this particular problem mechanically, the concept which we had already used. First and foremost, I to the power 18. In this case, the power raised is greater than 4. We will be dividing the 18 with 4. So 18. 4 is 16. We have got 2. Then I to the power 18 can be write to I to the power 2. Now, again, in this case, we are seeing that it is whole to the power 24 is there. So 1 to the power 24, it is 1 only, while I to the power 24 to the power 3, whole to the power 3. So in this case, we are seeing I square is there. I square we have already seen, under root minus 1 is equal to I square is equal to minus 1 plus 1 by I to the power 24. Again that power is greater than 4. So we will be seeing here 4 to the power 4 divided 24 divided by 4, 4 is 24. The remainder is 0. I to the power 0 to the power cube is equal to 0. We have to prove that LHS is equal to RHS. This is LHS and this is RHS. So minus 1 plus I to the power 0. Anything to the power 0 is 1. So it will be plus 1 to the power cube. So minus 1 plus 1, it will be 0. 0 to the power cube is equal to 0, and we have to prove also is equal to 0. So we had seen how easily we had solved this basic problem with the concept of the complex numbers. LHS equal to RHS. So this is the first class of the complex number, in which we had seen the basic concept of iota under root minus 1, and we had gone mechanically so as to solve. We had gone some of the concept, we had learned some of the concept in which we had seen how come that I can be elaborated to I square, then I cube, then I4, how greater than 4 power will be evaluated. So these are some of the concepts which we had seen. This is the very first class of the complex number. In the next class, we will see how we are writing a complex number in the two parts that we had already discussed here, x plus iy, where x is the real part and the iy will be the imaginary part, the addition, subtraction associated with the same. And if any issue is there, you can go through all this concept. If any issue will be there, just raise a question. I will be seeing all your doubts and we'll try to resolve as soon as possible. Till then, thank you.